right, nested quantifiers. We talked about this the other day briefly, and we've seen these exact examples here, but I want to make sure we understand them. So we have a statement here that says T of XY is the statement that student X is taking course Y. Okay, that's kind of like our thing a minute ago that student X went to country Y or whatever, right? So how would we translate this sentence here? Let's take a look at that one first. The way you work through these, the best way, in my opinion, is to ignore all the quantification, ignore all the negation. Just read that sentence right there. That's pretty easy, right? What is that saying? Yeah, some student in X is taking course Y. Now, what is it saying? It's saying that it is not the case that student X is taking course Y. Or, as you put it more simply, which is student X did not take course Y. Okay? Now, what are we saying it means? So close. Yeah, really good. Close. So remember, the domain is all courses and all students here, Salt Lake Community College students. This is saying for all students in the domain of Salt Lake City students, Salt Lake Community College students, it is not the case that that student has taken that course. Okay? That's kind of a weird statement. Okay? Let's see what that means when we do the rest of it. Now, this makes a lot more sense when you throw in the final quantifier, right? So what we're saying, there exists some course in the domain of courses, which is all SLIC courses, such that for all students in the domain of X, that it is not the case that that student has taken course Y. What is that saying? There's some class that nobody's taking. That's what that statement is saying. There's some class, there could be more than one, but there's some class. Remember, we're not using exactly one. So let's try that again. There exists some course such that all students, it is the case that they have not taken that class. Okay? There's a course that no students are taking. Okay? I get a puzzled look. Okay. So would you agree that if I stated this as there exists, do you agree with this statement? Let's start there. There exists some course Y such that for all students, it is not the case that those students are taking Y course. Would you agree with that statement? Based on just the math of the formula.
Yes.
Okay. Do you agree that that statement is the same thing as saying that?
Yes, I do.
Okay. Does that feel good? Okay. All right. Let's look at the next one. Again, how do you start reading these? Ignore the negation. I just read this. Okay. So again, it's simple. We already know what that is. There's some student X is taking course Y. Okay. Well, now it's saying there exists some course that student X is taking. Right? Well, duh. That's probably true. Right? All right. Now we're saying for all students, there exists some course that that student is taking. What is that saying right there? Forget the negation for a minute. What is that saying? Yeah, every student's taking a class or more, but every student's taking a class, right? But then we say it's not the case that, right? So it is not the case that all students at SLIC, all students X in the domain of students at SLIC, right, so it is not the case that for all students X, there exists a course such that that student is taking that course. So what is that saying? Not quite. It's not quite the same as the one above it.
There is no course that all students are taking.
That's what the first one says. Let me read it the mathy way again. So let's read this without the negation, okay? I'm saying for all students at SLIC, there exists a course such that you should have seen that. such that really? This is really freaking annoying, man. I'm trying to be cool about it, but man, it's losing my cool here. Such that that student is taking that course. That course. Pardon the poor handwriting and the skipping slides. Do you agree with that statement if I leave off the negation? For all students at SLIC, there exists a course such that that student is taking that course. Do you agree with that statement? Again, if I'm ignoring the negation. Do you agree that that's what this squared box right here is saying? Okay. Well, now I'm saying that it is not the, really, man, you're driving me crazy. Not the case that. It is not the case that for all students at SLIC, there exists a course such that that student is taking that course. Okay? So what am I saying there? You guys have seen it pop up like 5 times now. What is this? What's it saying? Some students are taking no courses, right? At least one student taking no course. Do you agree that that's the same? That's what that's saying? That's the part that's tricky. It's painful, right? Yeah.
The negation side, I just was putting at the universal, I was applying it to the existential.
Well, you shouldn't be. You should be applying it only to, you're applying it to the whole message, really, right? So I'm saying it is not the case, let me erase some of this mess here. So I'm saying it is not the case that there is some student that, sorry, let me say that again. It is not the case that for all students there exists a course that they're taking, right? It is not the case that all students have a course that they're taking. It is not the case that for all students there exists some course that that student is taking. So let's narrow down our search grid here for a minute. I'm going to go to the next page. It's got a cleaner set of stuff here. Okay. So we're going to narrow our domain down to 2 people. Bob and Joe. That's our domain. That is the entirety of Salt Lake Community College students. Okay? And I think their real names were Billy Bob and Joe Jack. Pretty sure. Could be wrong. Okay? Come on, that is hilarious. Okay, so Bob and Joe. So here's what this, again, I'm going to ignore the negation for just a moment. Okay? So I'm saying, without the negation here, I'm saying that, let's start with X is Bob. Okay? When X is Bob, there exists some course, we'll call it 2430, such that Bob is taking 2430. Dig that? Okay. When X is Joe, remember this is just like a loop. When X is Joe, I'm saying that there is some course that we'll call it 1410, such that Joe is taking that course, such that this is true. That's Joe, that's 1410. Okay? So in other words, for all of the students, there is some course that they are taking. Right? Now I'm saying, nope, it's not actually true. Maybe this will help. That's the same thing. The silence makes me wonder that if you got it or if you're stumped. It is weird. No question about it. It's very weird. Yeah. It takes practice to read this stuff, for sure. Yeah. So don't feel bad if your learning curve's struggling a little bit. It's okay. This takes practice. Does anybody not see it as the way I just pointed out? Does anybody need a little more clarification on that? Yeah, yes, that's very true. So that's why I was showing you to read it a piece at a time, right? To sort of baby step your way through it. And I'm going to give you one on the whiteboard that's really tricky that you guys are going to do together, okay, in a few minutes. All right, let's look at this last one here. Again, starting by ignoring the quantifiers and just looking at this statement, we're simply saying that student X has taken course Y. We know what that means, okay? Well, now I'm saying all of the students have taken whatever Y is. I don't know what Y is, but all of them have taken it. Would you agree with that? Anybody not get that? When I say would you agree with that, what I'm really asking is do you understand it? Right? Do you agree that that's what that's saying? Yeah? Okay? And you can fight me if you want. I'm okay. All right. So we're agreeing that this statement here is saying for all students, and I've got the domain squared off here, that all those students, Bob, Joe, Bill, everybody has taken course Y. I don't know what course Y is, but they've taken it. Okay. Now I'm saying, ignoring the negation, there is some course such that all students are taking it. Did we see that? Okay. Now I'm saying it is not the case that there is some such course that all students are taking. Right? So if you baby step your way through it, starting on the smallest piece and add on these quantifiers, it becomes a little bit more clear. So if I'm saying it is not the case that there exists some course such that all students are taking that said course, or all students are taking it, what am I saying? That's the first one. Oh, no, you said it differently. Say it again. There's no course that all students are taking. That sounds right. See, I have to think about it. No course is being, okay, not quite. No course is being taken by all students. Say what you said again. Let me write it down. There's no course that all students have taken. That's correct. Yes. Yeah, you said it right. Yep. How's your brain feel, guys? It's good? Yeah. Yes. De Morgan what? These are three completely different sentences.
I'm saying the purple text here does not perfectly reflect this. It looks like that negative has been distributed in for like some students. This is all students, right? So did that?
Well, but no, remember that I'm saying not all students.
Right. So some students, right?
Okay, but
This doesn't say not all.
right, because look at what's going on here. I'm saying it is not the case that all students are that, man, that is always a hard one to say. It is not the case that for all students there exists a course such that they're taking that course. Okay? No, I understand what you're asking. Right, I understand what you're saying. So let's back up. Let me finish where my train of thought's going here. Okay? So for is not the case that for all students X there exists a course that student has taken. Okay? So that means for all of the students, there are some cases where that student is not taking a course. Right? So it is not the case for all. If it's not the case for all, then that means that there is some student that's not taking one.
That sentence right there.
Is a literal translation of that.
Well, it sounds like what you're. Okay. The previous section we went over taking.
Right. I understand what you're talking. You're talking about the fact that when I say some, I'm usually referring to this, right?
Can you move that negative deeper into the expression?
I can move it. Yeah, you can. You can rearrange this for sure. So I could De Morgan this, and it would become this T of xy. Sorry. Yeah, that would be right. Yeah, so this is saying there exists some student such that there is a course that there's not a course that they're taking. Which is what this is saying, yes. So if and I understood your question, right? His question was this: is this right here? Is that what you're seeing that? Okay, thank you. I appreciate that. I'm glad somebody knows what's going on. Maybe I need to get another glove here. Oh my gosh. Thank you. I'll try to write it some other weird way. Okay. That's annoying. So the question he's asking is this, I'm not going to touch it, I'm going to put a little thing there. Is that student the English version of a De Morgan version of that statement? That's the question he was asking. And the answer is yes, it is. Okay, and the reason we didn't De Morgan it to display it is because sometimes you have to mentally De Morgan it to just say it correctly, right? You don't always have to do it. You have to be able to look at a statement like this and just know what it says or understand what it says. And sometimes that means it'd be a little bit plainer English to just De Morgan it, right? So I'm glad that came up. I'm glad you brought that up. Does that answer your question? Yep. All right. We good? Okay. Okay. They need to make a triple glove, so that covers 3 fingers. I have another one of these gloves. Maybe I'll cut the finger off and put it on. All right. So translate to English. Okay. And the domain is for both variables x and y is all integers. All right. That's the domain. Okay. So I'm asking the question. Yeah, I see it now. I see why my middle finger is touching right there. All right. So I'm claiming, let's just see if we can walk through this. So what did I tell you? Ignore the quantifiers, right? So ignore those. And what do we have here? Let's look at this in little simple stages. I have something and something, therefore something else. I have a P and Q, therefore R, right? Okay. And if to be clear, we should put parentheses there. It's not required, but that makes it a little bit more clear. Okay. But do you see that that's what I have there? That's all that is. Does everybody understand that? Okay, we good? All right. So, ignoring this, I'm simply saying that this is the P and Q here. I'm saying if this, therefore this. Well, what is the if? If x is greater than 0 and y is greater than 0. Therefore, this crap. Right? Okay. All right. So, pardon my plain speech. Okay. So, I'm saying if this is true and this is true, therefore this will be true. All right. Again, forget about the quantifiers. What am I saying? If x is greater than 0 and y is greater than 0, therefore x plus y will also be greater than 0. That seems true, right? Okay. Well, now, what am I saying? I'm saying that this is true for all integers. I'm saying for all x, which is all integers, and the fancy symbol for integers is the little weird-looking z there. And that's literally negative infinity to positive infinity, right, of whole numbers. So I'm saying every one of those, and every one of those again, the same domain, if each of those numbers are above 0, when I add them together, it will be greater than 0. Right? And that is true, obviously. Okay, so we're saying for every 2 integers, if these integers are both positive, then the sum of these integers is also positive. Okay, that one feel a little bit better? The math ones are a little easier sometimes instead of the English ones. Okay. In other words, for all positive integers x and y, x plus y is positive. That's a simpler way to say that. Okay. But in a proof, that might be needed to write it that way. Okay. Translate this one to English. The domain, again, is all positive integers. So the fancy symbol for that, which we're going to learn more about this later, is a z with a plus sign there. All right. So what am I claiming here? For every positive integer x and every positive integer y, so pick any positive integer. So 0, well, we'll go with 1. We'll talk about that later. 1 to infinity, okay? And then any other number from 1 to infinity. If I add those together, it will be greater than 0. I think we all agree with that statement, and we understand the symbols for it. We good? All right. For every 2 positive integers, the sum of the integers is positive, which is what we just said, or the sum of 2 positive integers is always positive. Those are 2 ways to say that same thing. Okay? Questions on those? To the whiteboards. So I think most of you got this one. Let's take a look. Actually, let's try to read it together first, just to make sure we understand it. I know most of you got it, but let's look at this. This simply says, again, baby steps, right? A piece at a time. This says that person X is friends with person Y. Right? Pretty straightforward. Person X is friends with person Y. Okay. And remember, the domain, we just decided the domain was going to be all students or all people or all whatever. Okay. This one here is saying that this person, Y, whoever that person is, has a computer. All right? So without, ignoring the rest of this here for just a moment, we're saying that person Y has a computer and is friends with X. Agree with that? Okay? Now we're saying there exists some person Y such that he has a computer and he's friends with X. Right? Okay. So whatever I just said there, or this. So now I'm saying person X has a computer, or there is a person that exists such that that person has a computer and is friends with this first guy. Follow that? Okay? When all is said and done, we're saying for every single student, person, whatever our domain is, that person either has a computer or there is some person that exists that happens to have a computer and is their friend. So in other words, everybody has a computer or knows somebody with a computer, right? How do we feel about that? This statement says that for every student X in your school, X has a computer, or there is a student Y such that Y has a computer and X and Y are friends, right? In more friendly terms, in other words, every student in your school has a computer or has a friend who has a computer. Okay? Again, assuming the domain was students at school. How do we feel about that one? A little tricky? Okay, this is another back to the whiteboard exercise. And the f of x is still x is friends with y. All right, as we saw, this one's a little trickier. Okay, let's see if we can figure out what's going on here. So again, baby steps, right? So let's see if we can just isolate the parentheses at first, all right? So we're going to ignore the quantifiers. Oh, why are you doing this to me? Ignore the quantifiers. And look inside of the main parentheses here, right? There's this one, and then this is the closing. And what do we have going on here? We got a P, big P, therefore a Q, right? We just have a simple P, therefore Q, right? What is the Q is pretty easy. We're saying that Y and Z are not friends. That's pretty easy. So we're saying if whatever is going on here is true, then these two people are not friends. Agreed? Okay. So let's start there. Now, let's figure out what's going on in this mess right here. Okay? This is a triple conjunction, if you will. It's 3 statements being ANDed together. So statement number 1 is this one. We're just saying that X and Y are buddies, right? They're buddies. They're friends. We're also saying that X and Z are buddies. We're also saying that Y and Z are 2 different people. Different, stop it. I touched it on accident. 2 different people. So Y and Z are not the same person. Okay? So this is saying that if X and Y are friends, and X and Z are friends, and Y and Z are not the same person, then that means Y and Z do not know each other. Do we agree with that? Okay. So Oh, stop that. So let's look at this in the complete context here. There exists some person X, at least one person. We're going to call that one person. There may be two, but we're going to go with one, and that person is Bob. Okay? So there exists some person Bob. Every time you see an existential operator, what's the next thing you say? Such that. There exists some person, Bob, such that for all of the people in the domain, which is whatever we decided, students, people, humans, whatever, for all those people in the domain, and for any two people in the domain, if Bob is friends with this one guy from the domain, and Bob is friends with this other person from the domain, and that person are not the same person, then they do not know each other. That's what it's saying. How do we feel about that? So, again, this is breaking down, and I actually pulled this right out of the book. And the reason I pulled these out of the book is so you can go back and look at the book and see the more in-depth analysis of them, and also you can hear it here in the video. But notice what happens the way they do it in the book. They first look at this separate expression, which is exactly what we did. Okay? And it's just saying that if X and Y are friends, we walked through this already. Okay? Then once we look at that, we throw the quantifiers on there. We're saying there is some student X, which we called Bob, such that for all students Y and all students Z, other than Y, why is it other than Y? Yes, right? Say it again. Because Y and Z are different people, right? If X and Y are friends and X and Z are friends, then Y and Z are not friends. Okay? In other words, there is a student, none of whose friends are also friends with each other. Okay? How do we feel about this last one? This one's a lot easier than some of the ones we've looked at. So if a person is female and is a parent, then this person is someone's mother. Do we agree with that statement? Okay, so if a person is female and is a parent, then that person is somebody's mother. All right? So for every person X, what we're doing is we're translating this from English into an equation. Right? You have to be able to do this both ways. But particularly when you're writing a proof, you start off with the English and you turn it into math, right? So we're saying we're going to now change this into some formalized, robotic way of saying the same thing. Okay, so the second bullet point is saying for every person X, if person X is a female and person X is a parent, then there exists a person Y such that person X is the mother of person Y. Right? That's a really ridiculous way to say that, but you have to do that kind of thinking when you're doing proofs, okay? We feel okay with that statement, though? We agree with it? Yeah? All right, so now we see this new fancy way to say it, and we're just doing the reverse of what we've been doing, right? I've been giving you this final formula, and you have to undo it. So now you have this statement, and we're going to go with, okay, that f of x means that person is female. We're going to go p of x means that person is parent, and we're going to go m of xy, meaning x is the mother of y. Okay, so now that we have all this stuff here, let's see if we can make an equation out of it, right? So we're saying if a person is female, well, what's that going to look like? That's f of x, if they're a female, and they're a parent, therefore, there exists some person y, like so. Does that look good? Can you guys read that okay with all that writing on the board there? Okay. All right. Let's see if I'm right. Oh, and I've left off the quantification for everything. Okay. So the domain being all humans, right? So for all humans, if the human is female and is a parent, therefore there exists some other human, same domain, such that this human is the mother of that human. So what we did there successfully in just a couple minutes is turn this simple logical statement into a nice equation we could use in a proof if we needed to. Feel good? Okay. You could also do this one. Personally, I prefer this method. It's a little cleaner to read, in my opinion. But we're saying for all humans X, there exists such a human Y, such that if human X is female and is a parent, then therefore X is the mother of Y. Those are both accurate, okay? They're both valid ways to write it. And depending on the proof and what you're trying to rearrange to ultimately end up with, and when we look at the hummingbird proof, which I believe is next week, you'll see this stuff come into play. Negating nested quantifiers. You ready for this? We've already seen it. This is De Morgan's law, right? We've already played around with this, okay? So let's start with a simple one. If I want to negate this, we're just going to move the line and, I don't know, how do you make flip the sign, whatever, okay? Right? And so we end up with this. You agree? So this statement says, it is not the case that for all x there exists some y such that x times y is equal to 1. This is saying there exists some x such that there is not a y that can be multiplied by it to equal 1. Those are the same things. I can further negate De Morgan it, and I get this. Again, I move the line and I flip the sign. So now I'm claiming this. There exists some x such that for every y in whatever the domain is, numbers probably, it is not the case that if I multiply that x and all of the y's that I'll ever get a 1. These are all saying the exact same thing. We could do De Morgan one more time here, because what I'm simply saying is for all x, this isn't really, that's not De Morgan, scratch that. This is not applying De Morgan. This is just restating it, okay? For all x, there exists some x such that for all y, when multiplying x and y together, it will not be equal to 1. That's just saying it a different way, okay? But they're still the same. Everything's the same. All right, how do we feel about this?